going to be recording today's lecture. Unfortunately, I have a conflict at right at 11 o'clock here, so I won't be here today. I'll be on campus, but unfortunately, I'm not going to be in class. What I'd like to do is continue on there with our hearing and section on hearing loss. As you recall, last time we chatted, that we talked about conductive hearing losses or characteristics of hearing losses. Just to review, conductive hearing loss is any type of hearing loss that occurs either in the outer or middle ear. However, there's another type of hearing loss which we refer to as sensorineural. One of the big differences between sensorineural and conductive hearing loss is conductive hearing loss is most common among young children, although anybody could have a conductive hearing loss. And same thing with sensorineural, in the sense that anybody can have a sensorineural hearing loss, but it's the biggest cause of hearing loss in adults. So sensorineural hearing loss most likely in adults, children most likely to have a conductive hearing loss. Now there are again a number of different types of sensorineural hearing loss. One thing which is common to all sensorineural hearing losses, though, is that the hearing loss is due to a problem in the inner ear, that is the cochlea, the cochlea, or the auditory pathways. Remember, the auditory pathways are those neural connections between the inner ear and the cortex. Okay. We're going to talk about some of the most common types of sensorineural hearing loss. Again, there's literally dozens of different causes of sensorineural hearing loss, but we can really divide it into 4 different types, which probably make up roughly about 98–99% of all these sensorineural hearing loss. Now, the 2 most common of those that we're going to talk about 4 of them. But the 2 most common by far are a noise-induced hearing loss and presbycusis, that is, hearing loss due to age. So let's first of all talk about noise-induced hearing loss. Now, not too surprisingly, noise-induced hearing loss is due to excess noise. It can happen in a number of different ways. The most common types of causes of noise-induced hearing loss would be something like music, especially those people who are in bands, or if you happen to go to rock concerts and sit very close to the amplifiers, you're not protecting your hearing, that can be a big problem. Also, listening to recorded music, specifically iPods, in the last couple of years there's been a lot of research on that. And the noise levels that you can generate from an iPod reaches about 120 decibels. And that is really quite dangerous levels for your hearing. We'll talk about prevention of noise-induced hearing loss in a little bit here. The other common cause of noise-induced hearing loss is firearms, specifically people who hunt. They have a high rate of noise-induced hearing loss. Another group are occupational noises, people who might run chainsaws, work in noisy factories and are not wearing ear protection. And finally, those people who happen to be in the military, people Iraq and Afghanistan veterans, were finding a high rate of noise-induced hearing loss as well. It's in fact one of the most common problems with returning veterans is this type of hearing loss. Unfortunately, there's not a whole lot they can do in terms of when you're in that environment to protect your hearing. Now, there's 2 things which really are variables when we're looking at a noise-induced hearing loss. Okay? One of those variables is the absolute intensity. Generally, I'd mentioned before several times that when when noise levels get above about 90 decibels, that's essentially the same as shouting. That's how much noise that is. That is kind of the threshold of where it might be dangerous for most people. And as you gradually increase the intensity, then the more dangerous it becomes. In fact, that OSHA, which is the Occupational Hearing and Safety Administration, is a federal agency federal agency important for worker safety, they recommend that nobody exceed 115 decibels anytime, since that can cause immediate noise-induced hearing loss. So I mentioned that iPods can go up as high as 120 decibels in some cases. So it's something to be concerned about, and something but yet it's totally preventable just by decreasing those noise levels. Besides absolute intensity, the second thing we need to look at too is duration. What I mean by duration is the longer you're exposed to noise, the worse it is. It does have a cumulative effect. So in other words, if you're just exposed for a single incident, like for example, you go to a rock concert, and for most people it's not going to cause a hearing loss. However, if you repeated noise exposures, then your risk goes up exponentially. Okay. Now, one thing which is interesting about a noise-induced hearing loss is that it affects the high frequencies. Probably at this point right now, what I'd like you to do is skip ahead a few slides until you see an audiogram. I was going to wait to show you that, but I think in terms of it might be a good, okay, it's actually slide 8 of this current series. And then the audiogram looks something like this. Okay, let me just hold it up there. Okay, you can kind of see it. Okay. Notice on your audiogram that there are an x-axis, horizontal axis, and the y-axis, vertical axis. If you see up on the top here, you see a bunch of numbers across here. It goes from roughly 250 hertz to roughly 8,000 hertz. Okay, those are the frequencies that we do hearing testing at. Okay. Now, if we look at the, let's see if I can get this right here. If we look at the y-axis here, see numbers going, in this case, all the way from, this example goes from 0 to about 110 decibels. That's the threshold of hearing. If you're looking at, not looking at this particular audiogram that I have showing you here, but the other one which I have on the PowerPoints, you'll notice that some of the symbols are red circles, while other ones might be blue X's, like this. Okay? What this represents are the right ear and the left ear. Okay? And these are the thresholds of hearing for each one of these frequencies. In other words, we test at 250 hertz, 500 hertz, 1000 hertz. And in this case, you see the 0 up there. That represents the softest intensity that a person is able to hear that sound. So in this example, notice it's at 0. So the person could hear down to 0 decibels. But if you look in this other example here, you notice right at 4000 hertz that the circle is actually depressed. It's down here. That means that I have to make the sound to exactly, in this example, 60 decibels before the person is able to hear it. So looking at this, then we can get a good idea of the hearing for the right ear, which is the red circles, and the left ear, which is down here. Okay? So that's what we do. So again, just to reiterate, these are the lowest intensities that a person can hear sounds. The lower that these symbols occur on the audiogram, the lower on the chart here, the worse the hearing. Okay? Now how does this, now let's go back to the noise-induced hearing loss. Because what I want to do is play you several simulations of what it is like to have a noise-induced hearing loss. First example here represents speech and quiet for somebody with normal hearing. So this is kind of our